Hello chemistry students. Today we are going to be talking about density and volume and how they relate to each other and dimensional analysis. So let's get started off by talking about what the density equation is. Hopefully you've seen this before, but density can either be, the units are either grams per milliliter or grams per centimeter cubed. And remember that 1 milliliter is equal to 1 centimeter cubed. And that's why these units can either be centimeter cubed or milliliter. The top part of the equation is mass, and that can either be in kilograms or in grams. And the bottom part is volume, which can either be in milliliters or centimeter cubed, since they're actually the same amount of volume. To do the density equation, you simply have to identify what is the mass in the problem and then what is the volume, and then divide the two. So in a question like a sample of aluminum metal has 8.4 grams and the volume of the sample is 3.1 centimeters cubed, calculate the density of aluminum. If we were going to do that, we would see that grams was our mass, centimeters cubed was our volume, and we'd simply just divide them. 8.4 grams divided by 3.1 centimeters cubed. We divide that, and remember, whenever we're doing any kind of calculation in chemistry now, we are using correct significant digits. Since this one has 2 sig figs, and this one also has 2 sig figs, our answer is going to have 2. And that would mean the answer would be 2.7. And then the units are just copied, just like they are. It's called the derived units. They're being divided grams per centimeter cubed. And yes, you need your units always in order for the answer to be correct. Okay, so just one more thing before we switch slides, and that would be to manipulate this equation. So sometimes we'll be given the density and the volume, and we'll want to know what mass is. And this is just a simple manipulation. So to really show how we do it, you have density equals to mass over volume. If we wanted to solve for mass, since this is on the bottom, we'd want to multiply volume out by both sides. These two would cancel, and we'd have volume times density is equal to mass. So then you would be able to take centimeters cubed multiplied by a number that had grams per centimeter cubed, and then your answer would be in grams, and that would be because the centimeters cubed would actually cancel out. Okay? If we wanted to solve for volume, it's just one more step. So density is equal to mass over volume. We multiply out volume on each side, and then we have this equation, and then we would want to get volume on a side by itself, so we would divide by density. And so our new equation to solve for volume would be volume is equal to mass over density. So there's actually 3 equations that we have here. I'll just box this one in. This one is to solve for mass. This one is to solve for volume. And this one is to solve for density. There's also another way that we can solve for volume, and we'll be talking about that in just a little bit. And we will be practicing this in class when we come back. Alright, we can also use density in dimensional analysis, and it's quite useful. Since it is grams per milliliter, this is the conversion factor, grams over 1 milliliter. So if we were going to use the information from the last problem, which was, our answer was 2.7 grams per milliliter, this was the density of silver. Okay, if we started out and we wanted to know, if we had a certain amount of silver, say we have 1.2 grams of silver. Okay. And we want to know how many liters that is. Okay, so we're looking for liters. We would start out with our 1.2 grams of silver. Ag is the element's symbol. And then we put grams of silver on bottom because that's our units. Okay. Now we can use density here to put for grams. So this thing would have to be flipped, which is still equal. This is the same thing as 1 milliliter over 2.7 grams. They're both equal to each other. So we just flip it over. We put 1 milliliter on top, and then put milliliter on bottom, liter on top. We know that liter is bigger, and that there's 1,000 milliliters in 1 liter. So then we just take 1.2 divided by 2.7 times 1,000. And we get 4.444 liters. Of course, that's not in the correct or scientific notation or significant figures. So, since our question has 2, and we would want to get rid of these, the 4 rounds down, so our answer would be 4.4 liters. Okay, and so this one's kind of tricky. If you start out with a mass unit, start out with mass, and you need to go to volume, density is the only way that you can get there. And you use that with dimensional analysis. And so if you're given a mass, you have to put the mass from the density on the bottom. And if you're given liters, you just use density grams per milliliter. Okay, the volume equation, I know you guys have seen this before. This is the length times width times height. And the reason that we give this to you in chemistry is sometimes we will know something's width, and we'll know the height, and we will know the volume, and we can actually use it to solve for density. So an example of a question like this is we might have to solve for volume using length times width times height and mass, and we could solve for the density. So let's say that our length is 10 centimeters, and our width is, we'll just say that it's a perfect cube, 10 by 10 by 10, and that we know that the density is 7.3 grams per milliliter. Okay, and what we're looking for here is the mass. So to do this, we have our length times width times height, okay, and we also have density. So we're missing volume and mass. So we can solve for volume by taking our 10 times 10 times 10, which is 1,000. And then we can use our density equation to solve for mass. You remember was volume times density equals mass. And now we just plug in the numbers. We have 1,000 times 7.3 is going to give us a mass of 7,300. We're going to put that in the correct scientific notation since these two are placeholders. So we get 7.3 times 10 to the third grams. So knowing the volume equation can help us solve for density, and that will be something that you'll have to show me you can do on your test. All right, our last thing here is cubic volume. Sometimes this can be confusing, especially in dimensional analysis, because we use this centimeter cubed quite a bit. And I just want to make sure that we understand that the centimeter cube is actually a three-dimensional block, okay, and it holds 1 milliliter worth of fluid if you were to fill it up, okay. And the real tricky thing here is if we have to go from centimeters cubed to like meters cubed, or from centimeters cubed maybe to millimeters cubed. And this cube really changes how we use that SI chart, okay? Because we can still use our kilo, hecto, deca, base unit, deci, centi, milli conversion chart, but it's not the same. We can't say that in 1 meter cubed that is equal to, since we have 1, and this would be 10 and 100, that it's 100 centimeters cubed. That is incorrect. Okay, and the reason for that is that what that is saying is that there's only 100 centimeters cubed in 1 meter cubed. And so all that we're referring to with this is just one side. There's 100 in just this one side. We have to remember that cubed is really the length times width times height equation that we just talked about in the last one. So what we really have to do here is if we wanted to take what is 1 meter cubed equal to, or centimeters cubed, we would still need to look at this, the 100, so there's 100 centimeters in 1 meter. Now, to do that, we have to multiply that by 3. So it's actually 100 is the height times 100 centimeters as the width times 100, which is the length. Okay, so now we have 100 times 100 times 100, and we have 1,000,000 centimeters cubed in 1 meter cubed. And so it's a lot bigger when we're talking about this cube and how many of these little squares actually make up this 1 meter by 1 meter by 1 meter square. Okay, and then if we're going to millimeters, it would be the same way. If we had 1 centimeter cubed, you definitely want to put the 1 beside the biggest unit. In this case, it would be centimeters. And since there's only 10 centimeters in 1, or 10 millimeters in 1 centimeter, which this is actually, I think this is a decigram maybe here, or a decimeter. We would want to do 10 times 10 times 10, which would be 1,000 millimeters cubed. So you just have to remember that this 3 takes however many you would get on this chart, and you would times it by itself 3 times, as if you're doing the length times width times height equation for it. All right. Hope you come with lots of questions on next time that I see you, and hope this helped with your density and volume.